Today, this is a lesson that brings back memories for me because the first year that I taught AP Calculus, at the end of this lesson, I had a student, I taught at a boarding school, and this student was from Ethiopia, I think. We had kids from all over the world. That I was asking her how she understood the lesson and what she thought of it, and she said, it's all a bunch of hee 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 hoo hoo hoo, and that was kind of what she said about it, which you're going to see by the end of the lesson where she's getting that from. Because we are going to talk today about composite functions, taking derivatives of composite functions. And this is what we're going to do the next 2 days. So, most functions or equations are not as easy as, say, like y equals 1 over x. They're not as simple as that. There's usually a little bit more going on. Usually, or at least we have a whole new world opened up to us when we expand to include these, we have things like, let's say, y equals x minus 2 over x plus 5. Or let's say instead of y equals just the square root of x, maybe let's say we have y equals 9x plus 17, and we're taking the square root of that. Usually there's a little bit more meat to the problem. So, we have this set of functions called composite functions. And there are 3. There are exactly 3 composite functions that you need to worry about. We're going to do 2 of them today and how to take their derivatives today. And then the last one we're going to dedicate a day just to it, meaning next week. What would that be? Today's Wednesday, I think, so Tuesday next week. So, if you have, say, an f function and a g function, no matter what they are, your composite functions could look like this. Let's call that one h of x. Or your composite function could look like this. Actually, no, we're not going to do that. We're going to do this composite function. Or your composite function, and this is the one we're going to save for tomorrow, or next class, could look like this. Well, you maybe haven't heard the term composite function before, and maybe you have. I feel like, is it reasonable to say you've probably seen the notation that's there at the bottom of the screen before? Okay. So I'll pause for you to finish writing that. And then I'll show you the rules that will go with the first 2. Like I said, the last one we're going to save for next class. Now, when I was your age, and quite literally for many of you, I took calculus as a senior in high school. The rule that my high school calculus teacher taught me was first d second plus second d first. And we would go around repeating to ourselves, first d second plus second d first. And I did the same for my students, and my students thought I was speaking some foreign language because of it, or trying to put at least an accent on something. But when I have this written out, what this means is you're going to take your first function and you're going to leave it alone. And then you're going to take the second function and take its derivative. Then you're going to add, and you're going to take the second function, leave it alone, and then multiply it by the derivative of the first function. Now, I am choosing, because we do have a lot we're going to go through and a lot of examples, and I want to focus more on examples today, I'm not going to do the proof for why this works with the limit definition, but suffice it to say, the proof for why this is the equation is on page 119 of your book. So you can still feel free to go through and look through it and find out it's not just some magic that a mathematician threw at us. They went through the limit definition of the rule, went through and simplified as much as they could, and this was as simple as it got in the most generic of all cases. So let's do an example or two to show you how this works with a practical example. And do then a couple more examples to get you used to it. I brought up last time that you will have a skills test, and since I am doing 2 of these rules today, that skills test will be on Thursday next week. And remember, I said the good news is everybody's going to get an A on this test, because if you get anything less than 90%, I'm putting a 0 in the grade book until you get an A. And I'm going to make you keep taking it over and over again, because you have to have these rules down to go past next week in this class. So if you don't get it, even if you score, like even if you miss everything next week, I'll work with you until you get it. But just know that these rules are that important. We're going to depend on them that much moving forward. So as we go through, while some of the questions I give you on the skills test are those really easy ones that we've already done, just be aware most of the problems are going to be with this product rule and the 2 rules that follow, and combinations of those rules where you're going to need to use more than one rule in one problem. So, if you have questions, please speak up. Let's figure them out. The earlier we figure them out, the better off it'll be. Okay, so, our first example. Let's do this one here. I'll do this one without giving you much of a head start, but the ones that come up next, I'm going to want you guys to do them before I take off. On a problem like this, when I take the derivative of my function, I'm going to take the first function and I'm going to leave it alone. And then I'm going to take the derivative of the second function. Do you remember what the derivative of a sine function is equal to?
Cosine?
It was equal to cosine. And that is one that I personally would memorize. And we are going to talk more about the trig functions towards the end of class today. Then you're going to add, and you're going to take the second function, and you're going to leave it alone. And you're going to take the derivative of the first function. Do you remember what the derivative of x squared is?
2x.
Keaton's got it, and Alina's got it. And let me tell you, for the skills test, don't bother simplifying. Because that is one place I'm going to be nice to you. You're actually more likely to make a mistake while simplifying than taking the derivative. So if you leave it like that, I will be happy. Don't worry about simplifying that. But for everything else, simplify your problem. So this one doesn't simplify a whole lot. Really, all I'm going to do is move that 2x in front. And I can see there's just really nothing much else I can do. That would be my final answer. Alright, on a scale of 1 to 10, how bad does that rule feel? Show me with your fingers. 1 low, 10 high. And of course, for half of you, I can only see your ceiling, so make sure you raise up your hands high. Alright, so let me write a note before I move on. And again, you guys know that I do kind of rush through the notes. If I'm going too fast, slow me down. Wave at me, yell at me, whatever it takes. Put something in the chat. But on this one, I do want to write this note. You're not going to see this one much. If you're taking a derivative of something that's made up of more than two things being multiplied together, like let's say that we tacked on, this is a function we're not going to learn yet, but let's say we tacked on an e to the x back here, which we'll not get to that one, honestly, how to take the derivative of that till like halfway through the year, just because it's its own special situation. The rule is going to be similar, but instead of starting with the derivative of the second thing this time, as I write it out, I'm going to start with the derivative of the first thing because I think it's easier to see the pattern this way. All right, what do you see happening there? What's my pattern? I got my breakfast here. I can wait as long as you can.
The pattern that I see is like you're deriving like every other those numbers. I don't know, the composites, I guess.
Uh-huh.
Like
the pieces of the
going
composite.
down.
They each take a turn. And the apostrophe goes down for each something of x, but only one at a time. So if I do a problem very similar to the one I did before, but let's not put e to the x on it. Let's do a function I know. Let's say I do like sine x, cosine x. If I want to take the derivative of that function, I'm going to take the derivative of the first thing, leave the next two alone. Now I'm only going to take the derivative of the middle thing, and I'm going to put parentheses around the part that I'm taking the derivative of, so it's easier to see. And do you remember what the derivative of the cosine is?
Negative sine.
Negative sine.
X.
Perfect. And again, for skills test, although I'll tell you straight up, none of my problems on the skills test will have 3. Don't simplify. Or instead of leave here, let's say stop here. But in life, in everything else, simplify. So on this one, there's not much I can simplify, but there is a little bit. Actually, there's, there's only a little bit here. On your mark, get set, go. I want you to take the derivatives of these functions. I'm going to give you a head start before I do anything. We lost one. You are welcome to leave them in their first state. You do not have to simplify the problems. I am kind of making a point to simplify them just because in the past I've really focused at the stage of never simplifying, and I found after the skills test the students felt like they never should simplify. I'm okay to say from this point on, let's not simplify anything and just practice taking the derivative. But know that after the skills test, everything needs to be simplified. And I will also say, too, I'm not necessarily going to pause and not do lessons after the skills test, even if you haven't passed yet. But we just we're going to have to get you to pass as quick as we can because those derivatives will come up so much all year long. You're going to see these special rules more than any basic rule.
For the third one, is there supposed to be parentheses somewhere?
Nope. There still secretly is a product in there somewhere, though. That does not mean the whole function includes the product, if that makes it easier. There might be a piece you just take the derivative straight forward. Alright, Sathya, we are practicing problems. Everybody else, I'm going to scroll for a second. Sathya, get ready to take a screenshot. I want you to get a screenshot and then quickly copy down this. This is the rule we're using.
I got it.
Okay. And also, I'm going to ignore this e to the x that I had put on. I added that as something I was talking about later, but that wasn't part of the problem. Alright, and I do see that people are sending me things in the chat. I'm just not responding yet. I wondered about the writing out plus. Yes, Emily, it would be. Okay, when you finish all three, have a staring contest with somebody on the screen. And Claire, since I can only see a dark hood, somehow let me know when you're done too. Okay. Oh, that was even over the skylight, so thank you. I don't know which of you Keaton's having a staring contest with, but he's pretty intense about it. Alright, and Jared, I can't even see your forehead, so somehow let me know too. There we go. Does a thumbs up mean, yes, I heard you, or does a thumbs up mean I'm done with all three?
Oh, sorry, I'm done.
Okay. And Hunter, I can see your forehead, but I can't tell for you either if you're done. Because all I can see is your hair and your headphones. Alright. Now, the unsimplified version. We're going to take first d second plus second d first. And you are welcome to leave it there. If you chose to simplify, this is what it will simplify down to. On the second one. Oh, hold on. Big no-no here. The function does not equal this. The derivative equals this. You guys almost let me get away with that. Alright, on the second one, your derivative is going to be first d second plus second d first. Which, if you chose to simplify it, not much you can do to this one. And on our third one, this one, I have two functions in there. You do have to remember to take the derivative of each of them. For the first function, you're going to take first d second plus second d first. And all of that was just the derivative of that first piece. The second piece, there's no product involved. You do still have to take the derivative. but it's a little more straightforward. You're just taking the derivative of the sine. And if you chose to simplify that one, you're going to have some things cancel. That one will actually go all the way down to this. And again, you are welcome, more than welcome, to not simplify. Every time you add an extra step into a problem, you're actually more likely to make mistakes. So up until the skills test and through the skills test, I'm okay if you leave it unsimplified. In fact, yeah, depending on which program I use to grade it, I actually prefer the unsimplified often. Yes, Satya.
Are you gonna have like a praxis skills test before you take it, or?
Yes and no. I'm gonna give you, well, let me not commit to anything yet. Because we're doing this via technology, I actually have an option opened up to me that I haven't used before where I could let a computer grade it. But usually I do this by hand, and I make like 12 tests for up to 12 tries, or however many we need. And I usually give you a piece of paper that has 111 derivatives on it, or things to take derivatives of. And I tell you just straight up, I'm going to use these on the test. You just don't know which 10 or which combination of 10 will show up. And I make random tests based on that. Just point it at the ceiling like everybody else. Or at the wall or something, that's okay. And so, if I do it the way I've done it in the past, because I do still need to explore the technology a little bit to decide if I prefer that or not, then I won't necessarily give you a practice test, just because in this case, like I said, everybody's going to get an A. Your first test could be considered your practice test. So let me think on it this week, and by next class I can let you know.
Thank you.
Oh, Annie, you're going to make things difficult for me. Know where your thumbs up button is. Okay, now on to the next rule. We did the product rule. Next one is the quotient rule. And when I told you about Mascarum telling me that I taught her about hee-ho-ho-ho as the rule, this is the one where she really got that from. Because the rule here... Okay, so some teachers will use the word low, some use the word ho to represent low. Everybody really uses low, but my teacher taught me with the other one, so I do that one because it sounds more like either Santa Claus or Wilson from the TV show Home Improvement, if you've ever experienced that. But I'll write it out both ways so you can use the one you want. So, what that means in mathematical terms. This rule is a little more complicated. And again, I'll show you where to find the proof for this one. It's not just something that somebody said, I think this is what the rule should be. There is a mathematical reason, and this is as simple as it gets. So again, you might choose to say this as low d high minus high d low over low low. But I am going to bring up that the way I learned it first, and we usually just kind of stick with what we learned first, it was ho d high minus high d ho over ho ho. Again, kind of reminds me more of Santa Claus. Did any of you watch Home Improvement, by the way? Are you familiar with what that show is? When I was still even just a little bit younger than you, it was on mostly in the 90s. Do you guys know who Tim Allen is? He has a show now called Last Man Standing. His first sitcom was very successful. It was like the number one show on television at the time. He played a home improvement guy that was always hurting himself. And one of the best shows that's ever been made. And he had a neighbor that you never ever in the show for like 11 years or however long it ran, you never saw his face because he always was standing behind a fence, or they'd always position the camera so something was always in front of his face and you could only see his eyes. Kind of like for you guys, a lot of you, I can only see your forehead and maybe your eyes. And that was kind of the joke for the whole show, was that you never could see his face. And every time he saw Tim Allen's character, he'd always say, "Heidi ho, neighbor," and that was his saying. So I think that's why I usually opt for the first one. Alright, so let me do an example for you. And then I'm going to turn you loose. Okay? Well, let's change that back. When you take the derivative, you're going to take low d high minus high d low over low low. And like before, I am going to show you both the unsimplified and the simplified. For the skills test, just leave it there. Don't try to keep going.
Got the squared on the bottom.
I forgot the square on the bottom, yeah. See, there's enough pieces even I missed something. I've even got it in front of me. Now, on the first rule, if you mix up the order, it won't matter because you're adding. But on this one, if you mix up the order and take the derivative of the wrong thing first, it most certainly will matter because you're subtracting instead of adding. This is the one I want you to be more careful about. This is the one you have to be more careful about. And then let's look at the simplified version. You guys know how to go through and distribute piece by piece. And I'm even going to leave parentheses around the second piece on purpose for a moment, because I want you just to do one thing at a time. And since I have to distribute this in and also distribute the negative, I'm choosing to do just one at a time. Because again, the more math you're doing in your brain and less math you're doing on the paper, the more you're hurting yourself. Now I'll distribute the negative in. And I've brought this up before. It might seem strange to you. I am distributing up on the top of the fraction, but you might notice I'm not on the bottom. That is a very conscious decision. This is actually a huge hint for higher math. Always simplify or distribute in the numerator. Never simplify or distribute, in this case, the denominator. Now these are not, I should say almost always. When I say this though, like, it really is, this is a rule that's going to be helpful to follow, because you oftentimes will be able to simplify the top in a way that then will cancel with something on the bottom. It doesn't in this case. Just looking at it, I can tell you if I tried to factor the top, it wouldn't simplify with the denominator. But that does happen often enough that you want to keep the denominator in its factored form. You don't want to expand it because you want to look for the opportunities for things to cancel, and that's going to happen more if you leave the denominator alone. Alright, how do you feel about that rule so far after one problem? Scale of 1 to 10, 1 it's easy, 10 it's difficult. T6, alright. Alright, that rule is more difficult than the last one. But I have faith in you that you will be able to get it done. I'm going to throw at you let's throw at you a problem here, and then I'm going to talk trig. Now let's throw a couple problems at you. Okay, on your mark, get set, go.
Will you scroll up just a tiny bit?
Yes. So you probably want to see the rule itself, don't you?
Yeah.
Let me do this instead. Although, is that too tiny for people? Here's what I'll do. We'll copy this. Oh, try again. And bring it down. Is that all right? Okay. And of course, hopefully you have that rule written into your notes, because for your homework tonight, you're going to be on your own with it. You can choose whether or not you want to simplify on this. And I'm just going to wait till it seems like everybody's looking up at the screen, or most people are looking at the screen before I jump in. And Cormac, can I go ahead and move that rule out of the way? Okay. Oops. I did not mean to do that. I opened up my email here on the other side. And I just moved the email that I really, really need into the trash can when I hit delete. There it is. Okay. That's what I get for having more than one thing I'm looking at. There we go. I'm going to leave these ones unsimplified just because I might have enough space to simplify them. Depends on how ugly they get. Got ho d high minus high d ho all over ho ho. By the way, I can't see your notes, obviously, as you take them. Make sure, especially on this one, that the product rule too, on all these rules we're learning these next couple days, make sure you're not neglecting your parentheses, because leaving off parentheses changes the problem completely. All right, our second one here. Yeah, it makes me think of that too. All right. Ho d high minus high d ho all over ho ho. All right, check yourself, see how you did. If you didn't simplify, everything should be in exactly this order. Then when we finish, we're going to round out the day with some trig functions. And Emily, tell your sibling if he wants, I think it's a he, I can't see their face enough. If they want to jump in and do the calculus, then they can. But otherwise, they've got to leave you alone. Did you tell him, Emily? Either he has to do the calculus or he's got to leave you alone. Teacher said. All right, give me a thumbs up when I can move off the screen, when you've had time to absorb its brilliance. Kaomi, Hunter, and Mia, I don't think I saw your thumbs if you did put them up. Okay. And Kaomi, there we go. Okay. It's not that I want to rush you, I want to be sure I'm not leaving anybody behind as we go. Okay. Now. Now remember from our time with Trig, we've talked about how even though it feels like we only really spend time with 3 of the trig functions, there are actually 6. So we talked when we did trig identities during our pre-calculus section of the year, right at the beginning of the year. We talked about how the identities is the sine, which is opposite over hypotenuse. There's the cosine, which is adjacent over hypotenuse. And there's the tangent, that is opposite over adjacent. And of course, when we say that, we mean in terms of any triangle where there's an opposite side, an adjacent side to the reference angle, and of course the hypotenuse. Now, the 3 that you haven't spent as much time with are just their reciprocals. You flipped them upside down. So there was the cosecant, that was hypotenuse over opposite, or in other words, it was just a flipped upside down sine. There was the secant, that was hypotenuse over adjacent, or in other words, a flipped upside down cosine. And there was the cotangent, which was adjacent over opposite, or in other words, a flipped upside down tangent. And yeah, these can feel complicated if you haven't spent much time with them. The tangent and cotangent are easier to remember that they go together because they both have the word tangent in them. Whereas cosecant, cotangent, or cosecant and secant, it's a little more confusing. And the best thing I can tell you is just always remember C goes with S and S goes with C. What we're going to do is I'm going to find the derivatives of these 4 using the quotient rule. And, spoiler alert, trig identities that we did at the beginning of the year will be involved. After we take the derivative, that is. So, I'm glad that we did spend some time with those, because I know that none of us last year spent a huge amount of time on trig identities, because number one, in the Math 3 section, it's just not much of the curriculum. We do just enough to touch on them. Math 3 honors, you guys had such a different situation last year, and you only yourselves spent just a couple days on them. Where normally I've spent up to 6 weeks on trig identities when I've taught pre-calc before. So I totally recognize that this is not a strength necessarily for anybody that's in the room. But as we learn these trig identities, I'm going to take advantage of that and try to teach you some things about those identities that'll help you with the AP test. Because they're 100% you will see identities, trig identities on the AP test at the end of the year. So let's take this year to make up for what we missed last year. Alright, so I'm going to do these ones for you. And then the answer, so in other words, I'm basically going to prove them for you. I'm not going to just hand them to you, because they're really pretty simple problems to do. And I think it's good practice. And I'll let you have a little bit of a head start on some of these. So for example, here we're going to start with a trig identity. One of the things we learned here is your tangent is the same thing as your sine over your cosine. And the reason that was true was you had opposite over hypotenuse and adjacent over hypotenuse if you put in the sine and cosine. And you can use your fraction rules. Take the first one, leave it alone. Take the second one, flip it upside down. And you see that your hypotenuses cancel and you're left just with opposite over adjacent. So a way to quickly prove these are the same thing. So I'm going to use that form because I already know what the derivatives of sine and cosine are. I'm going to use that form of the tangent to take the derivative of it. Now at this point, I'm going to give you a little bit of a head start. If you don't finish it before I get to it, that's okay. But I want you to use the quotient rule, ho-de-hi minus hi-de-ho over ho-ho. And I want you to take the derivative of this fraction. And then I'm going to walk you through the simplifying just to make sure we simplify in the expected way. All right. Now you might not be to that part yet, but hopefully if you're not, you're almost there. Now these 100% we're going to simplify because there's an expected way for this to look. One of the things about trig identities is there are so many ways I can make this look and they all equal the same thing, but there's one expected simplification. So I'm going to start by simplifying where I can upstairs. The downstairs we're going to leave alone for a minute. Up on top I have cosine times cosine, so in other words cosine squared. Here I'm going to have sine times sine, which is sine squared. And then I have this negative here, and this one, they multiply together. In this case, because they're just one term and one term, I am going to go ahead and simplify both of those. I'm going to have plus. Now, anytime you see cosine squared plus sine squared, or sine squared plus cosine squared, you should have a red flag go up. I know we're not necessarily super skilled at these yet, but what does cosine squared plus sine squared equal, if you can remember? And Cormac, your hand is like above your camera, so I can't actually see it. All right, Mia, Annie, you got it. Annalena, I think you got it. Cormac, there you go. If this is not one you feel comfortable with yet, don't worry about it. But this is one that you're going to see in every upper level math class. Well, except for like a stats. They don't get into trig much. That does equal 1. So we had, just for a reminder, the Pythagorean identities that we studied. And the first one, we'll get to that in a second, yeah. The first one was this. So anytime you see this combination, it will always equal 1. We can do a review on that as you'd like. And, check it out, we have 1 over cosine, blah. 1 over cosine was secant, remember? From up here. So if we have 1 over cosine squared, what do you think we get here? I mean, Alina's already told me in the chat, but... what about the rest of you? if 1 over cosine is secant, what happens when I square the cosine?
It would be secant squared.
It would be secant squared. Done. That is going to be the version of the answer we're looking for, and that's the most simplified version you can get. So, in other words, the derivative of a tangent is equal to a secant squared. On this next problem, do you remember what cosecant was equal to?
1 over sine theta.
We put it in a fractional form, and then we use the quotient rule on that. I'm going to give you a head start. Go ahead and find the derivative of this. By the way, we are almost done. We're going to do the other 2 trig functions after this. I'm going to reorder the answers in a way to help you memorize them, and then we're done for the day. And I'm going a little bit fast just because I see the time, and I want to make sure I get you out of here at least by 10:33, if not before. Because today's lesson did have quite a bit packed into it. And, interestingly enough, we still didn't even hit the whole section in the book. There are parts we'll come back to after the skills test. So we have equals ho d high minus high d ho all over ho ho. Compare your work to mine, and then let's work to simplify. And it might be tempting to leave the answer here, but we don't. Convention says we don't. We are going to use trig identities on this. And realistically, this is fractions inside of fractions. I think that's a lot of the reason why. Because remember, cosine is adjacent over hypotenuse. Sine is opposite over adjacent. So by definition, if we went back to those original definitions, you have fractions inside fractions, which mathematically we never like. So, like I said, I want to help you simplify in the right way. In the expected way, rather. So what I'm going to do is I'm going to bring the negative out in front. I'm going to focus on just one of the one of the signs. And then I'm going to have what's left over here. Do you agree with me that this is still the same thing? It's just deconstructed a little bit? And I'm going to apply a trig function to each of these fractions. So first of all, what was 1 over sine? We started the problem with it.
Cosecant.
Cosecant. And what was cosine over sine? That one we haven't seen except for the top of the screen.
Cotan.
Cotangent. This is going to be the expected version of the answer. So when you take the derivative of a cosecant, we're going to get out negative cosecant x cotangent x. Next problem What was secant equal to? In terms of the basic trig functions.
1 over cosine.
1 over cosine. Go ahead and apply the quotient rule to that. Alright, so we have ho d high minus high d ho all over ho ho. I do want to simplify that. My negatives cancel out. This whole thing is 0. And just like last time, I'm going to deconstruct this so my cosines are separate. One is assigned to the sine, and one just has a 1 over it. And what is 1 over cosine?
The thing we started with.
The thing we start with, which is the secant. And what is sine over cosine?
Tan.
So, in other words, the derivative of my secant will be secant times the tangent. And we've got one more to derive. Do you remember what cotangent was equal to?
Cos over sine.
Cosine over sine. We want to put everything in terms of just sines and cosines, because we know how to take those derivatives. Go ahead and use the quotient rule on that. Last one you got to do. So I've got ho d high minus high d ho all over ho ho. And as I simplify, this one's going to be reminiscent of the one that was up at the very beginning with the tangent. But this time I do have this negative in there. Before we apply a trig function, we do want to factor the negative out. And then we are going to apply that rule that sine squared plus cosine squared was 1. And 1 over sine is equal to what?
Cosecant, so it'll be cosecant, negative cosecant squared.
Negative cosecant squared. So our derivative of a cotangent is a negative cosecant. Now, on the AP test and honestly, anything you do in calculus as we go forward, it is expected that you'll be able to pull these derivatives out and have them memorized, be able to use them just as easily as you would the derivative of x squared. Just honest truth. So, you have two choices. Neither one is better than the other. It just depends on your personal preference and how your brain operates. When you're taking the derivative of these last 4 trig functions, you can either go to the quotient rule, which honestly I've done plenty of times because I do not memorize well. You can go to the quotient rule and rederive it as many times as you need to be able to use it. The other thing you can do is memorize it, which again, I don't memorize well. Most of you memorize better than I do. So I wanted to write these out in a way that would be helpful to us if we were going to take the memorization route. I want you to notice just a couple patterns here. First of all, if you just look at how the derivative looks, they are kind of grouped together. That sine and cosine are kind of the derivatives of each other. Cosecant and secant, each, when you take their derivative, you get back the same thing, plus you get one of the tangents, cotangent or tangent. Tangent and cotangent, their derivatives kind of look the same. They both get secant squared or cosecant squared. Another pattern that doesn't necessarily jump out at you is anytime you take the derivative of something that starts with the letter C, and this is just a silly trick, but it works. Anytime you take the derivative of something that starts with the letter C, you get a negative. If you're a tangent, a secant, or a sine, you start with the letter S, those ones are all positive. So, do I expect you to have this memorized by the end of the day? No. Do I expect you maybe to keep these derivatives on a page where you can find them quickly at any given time? I think that'd be a good idea. And do I hope that you'd have them memorized by, say, like Thanksgiving? Honestly, yeah. Memorized or be able to quickly find them through the derivative process. But since we're not as comfortable with trig identities, I do expect most of you will probably take the memorization route. Just because with trig identities, I just feel like most of the people, we probably could benefit from some extra practice before we jump there. Okay, we went through a lot. Not only did we run into synchronous or the asynchronous time in class like we always do, we only have 5 minutes left of class as a whole. But this is where I'm going to stop. Like I said, this section actually does have more to it. The section itself was even longer than just this. But the rest of that part I'm going to come back to after the skills test. Next class, just for a preview, we are going to do the functions that look like this. And the rule there is called the chain rule. And we'll explain why next class. And we'll go through that last composite function. And I will probably go ahead and give you, like I brought up, if I do decide to grade by hand, which honestly, I probably will. I'll also go ahead and give you the 111 derivatives so you can see the examples and start working through those. And then we'll probably take our skills test Thursday of next week. And if you don't pass it by the end of the day on Thursday, and we'll just have you take it maybe even a couple times on Thursday if you have to. If you don't pass it by the end of the day Thursday, then we'll have you come to my office hours and try again. And then just set up times on your own time to take that test. And that will go on second quarter, not first quarter. Your homework today is the last thing, and the quizzes today, the discussion, all that. That's the last thing, the very last thing I'm going to put on first quarter. Everything we do next week, I'm going to put on second quarter. Do you have any